how to find out an AP, or rather how to identify a series, whether it's an AP or not. For example, if you're given these numbers 1 2 3 4 5 6 and so on, and then -100, -96, -92, -88, -84, and so on. How to identify whether these numbers are in an AP or not, whether this series makes an AP or not. Now you know that the difference between any two consecutive terms or any two terms in a row is always going to be the same, and if the difference is going to be the same, then let's say that difference is D, and let's denote terms by A, arithmetic progression. So we'll use A to denote it terms, and term is any number in the series. In a moment I'm going to explain the terminology that we use in AP, but before that just stick with me. We're going to denote the first term by A1, that's 1. The second term A2 by we are going to denote the second term by A2, and A3 the third term, A4 fourth term, A4, and so on. Now you know that you can get a number if it's an AP, then you can get a number by adding the difference between the numbers. But before that, if you want to find out if the numbers, whether the number are in an AP or not, so we'll calculate the difference. Here it's 2 minus 1, and you have to remember that you are always going to subtract a term which is lower in sequence from a term higher in sequence. So A3 minus A2, A4 minus A3, A2 minus A1, like this. So we are going to subtract 1 from 2 to find the difference. 2 minus 1, 1, then 3 minus 2, 4 minus 3, D, I'm going to find out 2 minus 3 minus 2. Number, I'm going to subtract number that is lower in sequence from number higher in sequence. 1, D is 4 minus 3, 1. So you can see that you can take two numbers in a row and the difference is always the same. That's 1. So this series is an AP. So how do you find out whether a series makes an AP or the number in the series make an AP? You find the common difference. If it's the same for two numbers in a row every time, each time when you take any two numbers in a row, then the series will be an AP. So you have to find out the difference, the common difference. D is called the common difference. Similarly here, it's 96, -96 minus -100. Going to be 96 plus 100, so it's going to be 4 between these two terms. Then these two terms, -92 minus -96 is going to be 4. Then these two terms in a row, -88 minus -92 is going to be 4, so it's always the same. D. That's how an AP works. The difference between two numbers in a row is always going to be the same. So here, if you want to find out whether these numbers are in AP or not, you just find out the common difference. If it's the same everywhere, then the numbers are in AP. Now we are going to explain or learn more about, not more, we're going to learn some terms that we are going to use while solving problems in arithmetic progressions. The first term is term. When we say a term in an arithmetic progression, that means a number in series. It's a number. For example, if this is your arithmetic progression, then each number here is a term. This is the first term, A1, this is the second term, A2, this is the third term, A3, this is the fourth term, A4, and so on. Then common difference. Common difference is D. It's the difference between two consecutive or two numbers in a row. Difference between two numbers in a row. That's called common difference, and this difference can be positive, like here is +1. It can be negative. Here's an example. Well, let's see an example here. Let's say it's -1, -2, -3, -4. So the difference is -2 plus -1. Sorry, -1 is 2 plus 1, -2 plus 1 is -1. It can be negative, and it can also be 0. That means, let's say it's 1. If the difference is 0, then the next term is going to be 1, 1, 1, 1, and so on. So the series, the number keeps repeating itself, but technically we would say we are adding 0 to it, so it's always increasing by 0. It can be 0. That's what. Then type of AP. An AP can be a finite AP. For example, numbers 1 to 50 is going to be a finite AP, and an infinite AP. For example, 1, 2, 3, 4, and so on. It keeps going forever. First term is denoted by A. But here if you see, then the first term is, I've written it as A1. You can write it as A1, but the AP starts with this term, so we denote it by not A1, rather by A. So the first term is A, where the AP starts. You can also write it as A1, but the convention is A, the first term. And the last term is not always there. It's denoted by L, but if it's a finite AP, you're going to have a last term, and here the last term is 50. So you're going to have a last term for a finite AP. It's the final term. Finite in a finite AP, it's the final term. That's what the last term means. So these are the terms that we are going to use in arithmetic progression.